Ever wondered what powers Netflix, Reddit, and even Amazon's own massive online store? The answer, in many cases, is Amazon Web Services, or AWS. In this video, we're going to demystify what AWS is, why it's so dominant, and then dive deep into some of its most significant internet-breaking outages. We'll explore what went wrong, why it mattered, and the crucial lessons we can all learn about the cloud's hidden vulnerabilities. Stick around to understand the real backbone of the modern internet. So, what exactly is AWS? Think of it as Amazon's cloud computing division. Instead of companies buying and managing their own physical servers and data centers, they can rent computing power, storage, and a whole host of other services from Amazon on a pay-as-you-go basis. Formally launched back in 2006, AWS essentially made its own vast global IT infrastructure available to everyone, from tiny startups to massive corporations. The core idea is the cloud, a global network of data centers that you can access on demand over the internet. AWS offers an incredible toolbox with over 200 different services. These can be grouped into a few core categories. First, you have compute services like EC2, which are essentially virtual servers, or Lambda, which lets you run code without thinking about servers at all. Then there's storage, with services like S3 for storing files and data. Next are databases, from traditional relational databases with RDS to high-performance NoSQL databases like DynamoDB. And finally, you have networking and content delivery, which includes tools to create your own private cloud network and services like CloudFront to speed up content delivery to users worldwide. On top of these, there are services for analytics, machine learning, security, and much more. This huge variety of building blocks is what allows organizations to build almost any application imaginable. So why do so many organizations choose AWS? The benefits are huge. A company can spin up new infrastructure in minutes, rather than the weeks or months it would take to order and install physical hardware. This agility is a game changer. Another key advantage is scalability. If your app suddenly goes viral, you can automatically add more capacity to handle the load and then scale back down when traffic subsides. You only pay for what you use, which turns a large upfront capital expense into a manageable operational cost. Plus, with a global reach, companies can easily deploy their applications closer to their customers around the world, reducing latency and improving performance. All these factors allow businesses to innovate faster and focus on what they do best, rather than managing data centers. To provide these services, AWS has built a massive global infrastructure. This is organized into regions, which are distinct geographic areas like North Virginia or Ireland. Within each region, there are multiple availability zones, or a GIT. You can think of an AZ as one or more data centers with independent power, cooling, and networking. They're close enough for low-latency communication, but far enough apart that a single disaster, like a fire or flood, is unlikely to take out more than one. This design allows customers to build highly resilient applications by spreading them across multiple AWS. If one AWS fails, the application can keep running in the others. It's a brilliant design for reliability, but as we're about to see, it's not completely foolproof. Despite this incredible engineering, even cloud giants stumble. AWS is no exception. While most issues are minor and quickly resolved, some outages have had a massive, cascading impact across the internet. One of the most famous examples occurred on November 25, 2020. A problem with a service called Kinesis data streams in the US East 1 region, that's the North Virginia region, triggered a chain reaction that brought down dozens of other dependent AWS services. Suddenly, websites, smart home devices, and streaming platforms went dark for millions. This event was a major wake-up call, and it's far from the only one. Let's look at a timeline of other significant disruptions. Fast forward to September 26, 2021. This time, the culprit was EBS, or Elastic Block Store, which provides storage volumes for EC2 virtual servers. The service experienced a stuck I/O issue again in the US East 1 region. This meant that any application trying to read or write data to its storage was effectively frozen. Because so many services rely on EBS, the impact was widespread, impairing virtual machines and a host of applications for about 8 hours. This incident clearly showed how a problem in a single, fundamental service like storage can have a domino effect, knocking over services that seemed to be running perfectly fine. Just a few months later, on December 7, 2021, it happened again. Another major outage, lasting around 7 hours, struck the US East 1 region. This time, the official cause pointed to issues with network devices. The failure cascaded, affecting core services like EC2, API gateway, and load balancers. The fallout was immense, disrupting major streaming services, online gaming platforms, and even connected cars and robot vacuums. For many users around the world, it felt like a significant portion of the internet had simply vanished. This outage once again highlighted how a single region, particularly the oldest and largest one, had become a critical point of failure for the global digital ecosystem. The pattern continued. On June 13, 2023, the US East 1 region experienced another significant disruption. Users reported high error rates and sluggish performance across a wide range of services, including Lambda, which is used for serverless computing, and IAM, the Identity and Access Management Service. The impact was felt by countless businesses and even public services that rely on AWS for their daily operations. The trend is undeniable. The North Virginia region, US East 1, hosts a disproportionate number of workloads. Its sheer size and the fact that many services are first launched there make it a magnet for developers. But this concentration also means that when it falters, the ripple effects are felt far and wide. Now, let's imagine a future scenario, say October 20th, 2025. Picture this. A massive global outage originating once again in US East 1. Popular apps like Snapchat, Venmo, and Fortnite are down. Even Amazon's own retail site is inaccessible. Banking and telecom services in multiple countries are disrupted. The root cause: a subtle failure in a subsystem that monitors the health of the region's load balancing network, causing a cascading collapse. While this is a hypothetical date, the scenario is entirely plausible based on past events. An outage of this magnitude would underscore just how deeply intertwined AWS has become with the very fabric of our digital lives and the global economy. So, what have we learned from these real and potential outages? Several key lessons stand out. First is single region risk. Many organizations, for convenience or cost, put all their eggs in one basket, often US East 1. To build true resilience, they need to consider multi-region or even multi-cloud architectures. Second is the shared infrastructure dependency. A fault in a core service like storage or networking can cause a widespread cascade. This means application design matters. Decoupling components and having fallback mechanisms is critical. Third, you can't rely solely on the provider's status page. Organizations need their own deep monitoring and automated failover strategies. Finally, this all points to the need for robust cloud governance thinking, strategically about which regions to use, how to secure them, and what the plan is when, not if, an outage occurs. The cloud is powerful, but it's not invincible. For both AWS and its customers, the journey ahead is one of continuous improvement, focusing on true resilience over simple convenience. Thank you so much for watching. I hope this deep dive gave you a better understanding of what AWS is and the complex realities of the cloud. If you found this video helpful, please give it a thumbs up and hit that subscribe button so you don't miss our next one. We love hearing from you, so drop a comment below with your thoughts or questions. Thanks again, and we'll see you in the next video.